Okay, so today I'm going to be looking at graphing linear equalities and equations. And these are notes for worksheets pages 3 and 4. So if you would like to watch and kind of get a big idea about that, I'm going to go ahead and start off with linear functions, linear equations. And what we're going to do is we're going to look at graphing using the form y equals mx plus b. And this is called slope-intercept form. So we get that name from the fact that the equation itself right here has both of them. So m is the slope, whatever number is sitting next to x, and it can have a sign, positive or negative, and it can have a number to tell you how far to go. Okay, so the sign is up or down, left or right, direction, positive or negative, and the number is distance. And then b is the y-intercept, which is simply the y-coordinate of the point where the line crosses the y-axis. So typically it'll be written like this if you wanted to write it as a point. All right, so we're going to take a look at, let me see, graphing the equation y equals negative 1/4 x minus 1. And remember that the graph, this represents every possible point, every combination of x and y that will work in this equation. So the graph is a line with all of those xy combinations. Those are all points that satisfy, or another way of saying it is make true that equation. And if this is an inequality, that could be, make the inequality true. So we're going to create this line with all of these points. Remember that a line has infinite many points. So if you had, if you tried to draw a line, if you want to draw a line, you only need to connect 2 points. Bam, there's your line. But when you think about that line going all the way across, and I'm sorry, this is kind of messy, there are countless points. I could not possibly put a dot on every single point. So there are infinite XY combinations. There's infinite points on that line. Okay, so we're only going to need a few of them to make the whole line, which is awesome because this is a relationship. This defines exactly what goes on. So how is this relationship with all of these x's and y's defined? Well, there's 2 things we're told. If you look at the equation, y equals negative 4x minus 1, remember it's got an m, it's got a b. So here the m is negative 1/4. Now this tells us a couple of things. The sign tells us up or down. So if it's positive, it's going up, or if it's negative, it's going down. And in this case, we know that this line will go down. Now, if you've ever driven down a mountain on a car or been on a roller coaster, going down a hill can be at various speeds, at various angles. So the number is what's going to tell us how fast or how slow going down that hill is going to be. So the number is a rate. Remember, speed, a rate. It's the rate of change. And when you're going down a hill, if you go down a great distance very quickly, that's going to be a big number. But if you're going down a hill very slowly, that number right there will be very small. So because the number is small, it's going to go down slowly. And we can tell that just by looking at that -1/4 as the slope. The negative says it's going to go down. The 1/4 is a small number. It's going to go slow. The other thing that the equation tells us, and I want to go ahead and identify that here. So later on, if you want to take a look at it, you can find where those things go together. There we go. The other thing we need to know, okay, we know we're going to be traveling down. We know we're going slowly, but where in the heck are we? Where do we start? So that is the y-intercept. So in this case, the y-intercept is -1. So remember, we can look at that as an ordered pair, 0, comma, whatever that is. So this represents the point 0, comma, -1, and that's where we start. So we start here, and then we use these directions to get us to other points. Okay. And in this case, -1 is just telling us it's on the negative side of the y-axis. It'll be on the bottom of the graph there, you could say. Okay. So let's put all this together and let's make our graph. Let me scoot that up a little bit. And I would recommend graph paper, but you know, this is fine. It would be a good idea to use a ruler to make all of the spaces equal. Because, I mean, you've got these blue lines here to use, that's fine, bam. And we can use that to label the y-axis, but it's really important to try to make the lines as uniform as possible. And if I measure this with the ruler, it's about 1/2 centimeter, about a little bit more. So I don't mind going just about 1/2 centimeter for each value of x. Okay, so once again, it's a little bit more than 1/2 centimeter, practically 3/4. But I don't mind just going 1/2 centimeter for x because it'll be easy to label that way. And I'm using my ruler every 1/2 centimeter and putting a mark. And it doesn't matter if these aren't perfectly the same. That really doesn't matter. As long as on the line, they're equally spaced. As long as the line is equally spaced between those marks, you're okay. And there's x. Okay, so thinking about my points, my starting point is at the y-coordinate -1. If I put that here, then I'm going to go up 1 and back 4, or down 1 and forward 4. So I think we'll be okay if we go by ones. So what I mean is, I was trying to make sure I had enough room to put points on here, and I think I will. So each of these marks will be worth 1. So this will go down to -5, -1, -2, -3, -4, -5. This will be +5, 1, 2, 3, 4, 5. And then going this way, 1, 2, 3, 4, here's 5. And backwards, -1, -2, -3, -4, -5. There we go. All right. So we always start here. So this is our first step when you actually go to apply it to the graph. So we're going to start at the point 0, -1. X is 0, y is -1 right here. And that's our intercept. Once again, that's because this line that we're about to draw is going to cross the y-axis right there. And now we're going to move from here according to our sign and our number. So we're going to take the slope, -1/4, and we're going to make it into rise and run. Now, we have two numbers, so that means there's two ways we can set up a fraction to equal -1/4. Since that's negative, that means either the top number needs to be negative, so it'd be -1 over +4, or the bottom number needs to be negative. So it'd be -4 on the bottom, and we'd have +1 on the top. So what is this telling us? If we go -1 over +4, this means we're going to go down 1 because the rise is up and down. So we're going to go down 1, and the run is horizontal, and numbers get bigger as you're going to the right. So we would go down 1 and then to the right 4 because you are adding 4. You're adding value. You're making it bigger. What's the opposite of that? The opposite of that is the other fraction, right? We switched the signs, made them opposite. So the opposite of down 1 is up 1, and the opposite of going to the right is going to the left by 4. So let's follow those directions. And it only takes 2 points to make a line, but let's try to make as many as we can to get across the whole graph. So I'm going to start here. I'm going to go this one. So I'm going to go down 1, and I'm going to go to the right 4. 1, 2, 3, 4, right there. And that's going to get me to the point, and I should label these, shouldn't I? But that'll get me to the point 4, -2. And we had started over here at 0, -1. So I've got a point here. And if I keep going, I'll go off my graph. But if you don't, if you feel comfortable, add yourself a couple more lines there. If you want to keep going, you can. And down 1, 1, 2, 3, 4, about right there. So if I go down 1, that means that y is going to become -3, right there. And if I increase that x by 4, I started at 4, I'll become 8. So this is the points, 8, -3, and you can check that using your scale marks. Okay, nice. Now, as a picture, down 1 to the right 4, down 1 to the right 4. That's what we did. All right, now let's do the reverse. Let's go up 1 and to the left 4. So we'll go up 1 here, get us to 0, 0, and then we'll go to the left 4, 1, 2, 3, 4. That's going to get us over here to x equals -4. So the coordinates of that point are -4, 0. And if we check the math, if we go up 1, that means the y coordinate went up by 1. So -1 plus 1 is 0. And if we go to the left 4, that means to subtract 4. So 0 minus 4 is -4. And once again, if you want to add some more lines or scale markings, you can go a little further if you want. It's up to you. But I'm going to go up 1 and back. 1, 2, 3, 4. And that's going to get me here. And if I look at the coordinates, that should get me to, let's see, -8, +1. That's what it looks like. Yep, because -5 is right there. 6, 7, 8. So -8, +1. There we go. So up and back, up and to the left. So that was our second step. Now we've got all the points we need. So last step, connect them all the way across. And remember, you have infinite many points, so that's why we put arrows at the end to show that it goes on forever. So you connect it with the line and put arrows at each end to show it continues. And if you're doing it on paper like this, you don't have a ruler, you just take your paper and pinch some of the points together and make a fold like that. And pinch it here, make another fold like that. And then bring the folds together. It'll kind of work itself out if you let it. There we go. And once you have pinched all your points, you will be able to open it up to a nice, neat fold that's a straight line because you cut your plan in half. There we go. See how that fold? You can see it right there. My fold is pretty much straight. Didn't even have to use a ruler. And I'm going to go ahead and mark it with my pen. And it's okay to make this thick if you're kind of like me. I had to have surgery. Can't write very well. But that's okay because we're not computers. This isn't going to be 100% perfect. And there you go. So that is how you draw a line. All right. And I'm going to go ahead and identify with the highlighter one more time what we did here. And then, bam, we're done. Okay, so thank you, and I hope you find this helpful.